Text edge. Right? Can I have your attention? Right, this angle here is equal to 30, right? It's equal to N4 because of tan chord theorem. So I'll say N4 is equal to 30 degrees because of tan chord theorem. Okay? Are you following that? And then TO is a radius because O is the center and ON is also a radius. Okay, so these two are equal. So I can say N2 is equal to 30 degrees. My reason angles opposite equal side. Okay? Alright? Are you following that? Then I need a third one now. Now to get the third one, okay, to get the third one, alright, I hope you are, this is a radius, okay, so that whole angle there is going to be what? It's going to be 90 degrees, okay, it's going to be 90 degrees. Now in triangle TON, we know that N2 is 30, which means this angle is going to be 60, based on what? Sum of angles in a triangle. So it's based on the exterior angle of a triangle, right? So this 60 plus the 90, subtract from 180, I'll get 30 there, right? But, yes?
You should say N4 is equal to NN4.
N4 is equal to?
NN. Because corresponding angles.
This one here is equal to that one there. No, it's fine. Okay. Remember, I didn't see that. Okay. I didn't see that. Did you see my solution? All right. So let's write all of them then. So we'll say M4 is equal to angle M, and both are equal to 30, and that's because of corresponding angles. And the lines that are parallel, it will be NP is parallel to MO. Okay, you can write that. Another one, I'll give you mine, the third one that I saw. So for me, I was going to say angle ONR is equal to 90 degrees. My reason, tan perpendicular to radius. Okay? And then O1 is equal to 30 plus, okay, I would rather say, this will be equal to angle T plus angle N2. And my reason there is going to be exterior angle of a triangle. So O1 is going to be 2 times 30, which is 60 degrees. And then in triangle NOR, okay, we want R. Angle R is going to be equal to 180 minus 90 plus 60 degrees. And your reason here, sum of angles in a triangle. So angle R is equal to 30. Okay? So we have got 4 angles so far that are equal to 30 degrees. Okay. The first two are easy to see. This one here, it might be a challenge to see. How many of you saw that? Okay, you see, I was aware that angle M is 30, but I've got my own way of doing it, but let's not go there. So, angle M, how many of you saw that it's equal to 30? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 30. Right, and you saw it 14. Okay, so it means the other 13 of you minus 2, that's 11. Did you see it? Okay, that's fine. And he's also number 3 because he didn't do the work. And he's team there. All right. Okay, then quickly, let's do this one here quickly. Right, determine RNT. Now, this one is now very easy. Our RNT, that's RNT. So we want that angle there. Okay, this angle. Right. So it's very simple because we know what R is. Okay, those of you who didn't get that R there first, like how I would have done. How did you get the R? Yes.
N4 is equal to 30 because of cycle theorem.
N4 is equal to 30
because it's equal to T.
Yeah. Good. How did you get this?
We're trying to find that angle, RNT, right?
Before we go there, I'm just asking. Okay? Wait in terms. I'm just asking. If you had provided these three, right, without writing down the value of R as 30, how were you going to get the value of 30 degrees for R? That's my question. Don't worry. Finding this angle is easy now because we have got this T and we have got that R, so it's easy. But I'm just asking as an extra question.
You find only 3 because it's equal to the sum of the interior opposite angles. I mean the interior opposite of TON.
So what that means is, if you probably got this M equal to 30, right, to try and get that R equal to 30, maybe you needed more working hours. Am I right? How did you see it? Yeah. N2 and 3. Alright. Then goes in the same set.
And then P2 will be 30 plus 19
P2 will be 90 plus 30, which is 120.
Then we already know N4 is 30 from the previous question. Then for R, it will be 180 minus 120.
Thank you so much. Is that what you saw as well? What are you seeing?
I said info is equal to OP.
And then?
And we already found that N2 is equal to 30. And then TMP is equal to 90 degrees because of the angles in the semicircle. So then N3 would be equal to 60. And that means that it's equal to P1, which is also 60. Because, yeah. And then I used angles in a straight line, and then I found that P2 was 120, and then I did.
Alright. At least you were thinking. Okay, at least you were thinking. Alright. Let's carry on. Alright, since I got my R, then my T, finding that angle N is very simple. So I'll say in triangle RNT, okay, angle T plus angle R plus angle RNT will give me 180 degrees, and that's sum of angles in a triangle. So we get our RNT as 180 minus 60 degrees. That will give you 120. Okay. So that's step 4. Okay. Let's move on to the similar triangle. All right. The one, okay. Similar triangles now. Those of you who didn't take part in the online lesson yesterday, make sure you pay attention carefully to what I'm going to say. So you two, sorry boys, can we have one lesson? All right, here, please, do me a favor from now on. When you want to prove that any pair of triangles are similar, it's so easy. The only challenge is that in grade 12 you have got the circle as well involved. So you need to know your circle geometry theorems. If you know them, then you shouldn't have any challenge. Okay? Let the question guide you. Okay? Let the question what? Guide you. The names of triangles, okay, that are similar are written based on corresponding angles that are equal. Okay? So, if you are given, like in this case, two angles that's R and P. Okay, let's just label it. We have got R and P, which is this one here.
Sorry for the interruption. Teachers, if you are in the video, can you kindly make your way to the library now if you do not have a class, and make sure that you are there at 9:55 promptly, please, if you do have a class. Thank you so much, and I'm sorry for the interruption.
Okay. So, those are our two triangles. I'm sure you can see, pay attention. Pay attention. You can all see that angle R is a common angle. Now, when you have two triangles, if you want to prove that they are similar, you just need to prove that any two pairs of corresponding angles are equal. Okay? The third pair is based on sum of angles in a triangle. Okay? But there are times when you can prove the third pair using theorems or geometry concepts. Okay? But it's not important. If you can prove that two pairs of corresponding angles are equal, the third pair is automatic. Okay? So, already we know that this angle is a common angle. So it means I'm almost there. I just need to prove that. Yes, it means I just need to prove that angle N is equal to angle T or P is equal to N. That's all. And then once I do that, the third pair is based on sum of angles in a triangle. So, previous lesson, this is where I stopped. Yes. Right, we have got two triangles, that's R and P. Let me just indicate R and P. So that's R, N, and P. That's the triangle there. Okay, and we have got RTN. Okay, that's RTN. Okay, and I'm sure you can see that there is a common angle from the diagram and also from the names of the triangle. Okay, as I said before, if you are requested to prove that two triangles are similar, okay, you should find it as a grade 8 or 9 question. Okay?
Very good.
The only thing is that you just need to know your circle theorems, that's all. But otherwise, the concept of similar triangle is a grade 8 and 9 question. So, number one, angle R is common. Okay? And then the second pair of angles will be angle N and angle T. Now in RNP, that's RNP, this is N and that's N4. In RTN, this is angle T. And we already proved that N4 is equal to T because of the tan chord theorem. So I can just write here N4 is equal to angle T, and that's because of the tan chord theorem, or you can say proved in whichever number you proved it. Okay, you can write that. So tan chord theorem. Right. Now, once you do this, you have got two pairs of corresponding angles that are equal. The third pair is automatic because it's based on sum of angles in a triangle. Please, there is no need for you to try wasting time trying to figure out why is angle P equal to angle N. There is no need. Okay? There is no need. Once you have got these two pairs of corresponding angles, then you must be happy that you are almost done. Right? So number 3, it will be angle P, but that's P2. Okay, P2 is equal to angle N. Now that N, I'm gonna call it RNT. RNT. And your reason, sum of angles in a triangle. Then you can say, therefore, triangle RNP is similar to triangle RTN. And your reason there, that's triple A.
Okay.
Okay, and then you are done. All right? Please, there's no need to get nervous if they ask you to prove that two triangles are similar. There's no need. Okay? You can use the names of the triangles that you are given, okay, because the triangles are named based on corresponding angles. Okay? So you just compare the angles and see how are they equal using the geometry theorems. Okay, then the last question, I'm not sure how some of you did it, but there's a part which is very tricky in this question which you have to show. Okay, it's not like just straightforward, just like that. Right, so in my case, this is how I'm gonna do it. I'm going to ask you later how you approach the question. Okay, so we're supposed to prove that TW times Rn times half RT times, is equal to half RNT times NP. Okay? So first thing, I'm going to use this, okay, to get my solution. So if you look at TW, that's this line. It's part of TN. Okay? It's part of what? TN. Then you have got RN, which is this line. Right? Then we have RT, which is this one here. Okay, and we have got NP. I'm going to use green for NP. So we have got that, and this TW is going to be in green. Okay, which means my two triangles there is going to be, maybe I can call it TRN and triangle TNP. So I'm going to prove similar triangles there. But before I do that, okay, because of this TW, it's part of TN, okay, I'm going to prove first that angle W2 is equal to 90 degrees. Okay, I'm going to prove that it's 90. Because for you to get this 2 here, to say that Tn is 2 times Tw, you have to prove the existence of an angle which is equal to 90 degrees there, because it's not given. Okay? It's not given. So we know that this is 30 from the previous question. Okay, we know that's 30, right? We can find the size of this whole angle. Okay, we can find the size of this whole angle. What will be the size of angle MOR? MOR. Remember, we know the size of M, the size of R. So, okay. So I'm going to say MOR. Okay, please, I want you to know that you might see it differently, but this is how I'm going to approach it. Triangle MOR is equal to 1/8 minus, can I have your attention? It's equal to 1/8 degrees minus 30 plus 30, because we know that angle R and angle M, they are equal to 30, because we proved that in the first part of the question. So, angle MOR will be equal to 120 degrees. Okay? Now, this angle here, it's an exterior angle of triangle OTW. Okay? And I know that this is 30, so I'm going to say angle MOR is equal to angle T plus angle W2. And My reason for that is exterior angle of a triangle. Okay, so W2 is going to be equal to 120 minus 30 degrees, and that's equal to 90 degrees. Okay, all right, please, you cannot say that TW is equal to half of TN until you prove that W1 or W2 is 90 degrees. Using what? Theorem 1. Okay, so I now have it. Once I have this, okay, then I can now say that TW is equal to half of TN. And my reason, line from center, perpendicular to chord. Okay, so now I can even write this. 2TW is equal to TN if I want. Okay, so I've got that part. Now the next thing is to prove that those two triangles are similar. That is triangle TRN. Please, I am saying it before proving in terms of the corresponding angles. Right? So for now, I'm going to call it TRN and triangle TNP. Okay, so I'm going to move on to the next page. Please, I want you to know that if you didn't do this part here to prove that this angle W2 is 90 degrees, and you prove the similarity of the two triangles, you won't get full marks. Okay, you'll get maybe 3, okay, or maybe 4, but not all 5. Okay, so let's go to the next page. Now, before I move on, we already know that this is 30, that's 30. We already know that. Okay, and we know that this angle here is equal to what? It's equal to what? That angle, the TNP. It's equal to 90. And so we have got TNP and we have got RNT. Okay? All right. So this is 30, that's 30. If this is 90, okay, I have my tangent there, and this is a chord. Well, that may make sense. That those two triangles are similar. That is TNP and TNR. Remember I said TW is part of TN. It's part of TN and RN. We've got our RN there. RT, which is that. NP, which is this one here. So which two triangles are similar? That's the question.
So, the other one, you meant to use the triangles to prove earlier on in the previous question.
So you want us to use these two triangles here?
Yeah, the ratios for those two triangles.
Okay. So we are talking about these two triangles. And that one there. Okay. So let's move on now. So those two triangles that are similar, the ones that you are supposed to prove that they are, we have proved that they are similar. So I'm going to write the ratios of their corresponding sides. So it will be Rn. So I'll say in triangle RNP and RTN. In triangle RNP and RTN. Okay, we are going to have Rn over RT is equal to NP over TN. That's also equal to RP over Rn. And the reason is because triangle RNP is similar to triangle RTN. Okay? You follow me then? Now, I'm sure you can see that these 5 marks, they had nothing to do mainly with the proving that the triangles are similar, because we had already done it in 8.3.1. So, to show that W2 is equal to 90 degrees is a major part of the question, then we want Rn, okay? Let's see. We have got RT there, so we want RT, we need NP, and we also need what? Tn. So I can write Rn over RT is equal to NP over Tn. But we already know that Tn is 2 times Tw. So I can write this as Rn over RT equal to NP over 2Tw. Okay? But how are we supposed to show it? Just swap these two, cross multiply. So, or I can just leave these 2 there. I hope you understand.
Yes.
So I'll cross multiply like that, but I'll multiply by the Tw. I'll leave the 2 there. Okay? So if I do that, I'll get Tw times Rn is equal to a half times RT times NP. Okay, and then we are done. Okay, so the major part of the question was here, this part. How many of you did this part?
So why?
Okay, how many of you proved that W2 is 90 or W1 is 90? Or you proved that NWO is 90 degrees? Raise your hand. 1, 2, 3, 4,
Sir.
4, 5.
No, sir.
Okay, only a few of it. The others didn't do it.
So why? They didn't do like that.
Sir?
So why did you have to prove it like
Okay. For you to end up having this half, okay, it comes from theorem 1. Line from center, perpendicular to what? To chord.
So WO is parallel to NP.
WO,
Parallel to NP. MO, the whole line is parallel to NP.
okay, can you come again? You're saying this whole line here,
So it's given that it's parallel to NP.
okay, and then,
Well, then it's trying line from what's parallel to one side triangle. For theorem 1.
okay, I'm talking about this line being parallel to that.
Yes, we gave it as parallel to each other.
No.
But how does that help you to say this is 90?
What's corresponding? So isn't it line from one line parallel to one side of triangle? So you can use it.
Okay, unless, can I have your attention? Unless if you say that this angle is 90 because there are angles in a semicircle, therefore W2 is equal to that because they are corresponding angles. Did you do that?
No.
You see, the main issue is not about what you are seeing, it's about writing it what? Down. Did you write it down? Did you prove that W2 is 90? Yes.
So I did it differently. I proved similarity between triangle TWO and TNP. Then I said TO over TP is 1/2 because it's a radius over diameter. And then I used the proportion theorem to say that therefore TW is half NT.
Well, it would be correct. As long as you manage to show how you end up